All right, so graphing inequalities in the coordinate plane. We graph it just like a line. So if you guys are having a tough time with lines, go back onto IXL. The line practice is S2, S3, all the S's, S5 to 11, S13. You should be able to, on there, get some M and B practice. You're going to realize today that if you don't like M and B, I will show you the table if you forgot how to use the table from the calculator, but you really need to know M and B. It'll get to this on the second page. It'll become apparent why. All right, so the first thing when we graph inequalities is that if we have the equal sign underneath, so this is greater than or equal to or less than or equal to, we use a solid line. If there's no equal sign underneath, that means it is not equal on the line, and we use a dotted line. That is why on the regions, they say all graphs are done in pencil. Because even when Mrs. Pelkey and I do this like a million times, we even forget. We're like, okay, we'll do a straight line, and we forget that it needs to be dotted. You also have to shade the correct side of the line. So this is when you have to understand that 1 dot, 2 dot rule thing and know that this first one, these are greater than. Greater than or greater than or equal to, you're going to shade above the line. We also say sometimes shade up. If it's less than or equal to, we shade below the line, or sometimes we say shade down. Okay, if you really don't understand above, below, up, down, then I'll show you another way to do it for shading. Check the solution by picking a point from the shaded area to see if it makes the inequality true, which I believe if you look on T1, that's what they start out with there on T1. They'll say, given this point, is it a solution to the inequality? Okay, you have to plug it in and see if it works. Okay, a linear inequality describes an area or region of the coordinate plane separated by a boundary line. Each point on the dashed line is not a solution if it's on the dotted line. If it's on a solid line, then it is a solution. Now, the regions obsesses over vertical and horizontal lines. Why? Because it's the one thing that you guys struggle with. So you will see it, and you have to know how to do horizontal and verticals, okay? I'm going to teach you, and I will over teach you 3 or 4 different ways to kind of help get it into your head what the difference is, and that it's just not one way to do them, okay? So I'm going to make it a little bigger so that you can see it. All right, so if we look at the first one, x is less than 1. First of all, this one, if it's an x equal line, this is a no calculator problem. You cannot check it on the calculator. Not even the fanciest calculators that they make today will graph x equal lines. Okay. Now, you got to figure out which way x equal lines go. This is how I think is one of the best ways to remember. In your brain, you think x-axis. So all of you think, okay, this is the x-axis, it's horizontal. If it's an x equal line, it's opposite of what you think. It's not horizontal, it is vertical. So that's the first thing. Opposite of what you think, this is a vertical line. And if you write that on the regions, that is considered showing your work. I know it's a vertical line. You cannot do m and b with this because it's not a y equals mx plus b thing. So you can't do you can't do m and b. Remember, vertical lines, when you guys did lines last year, you did slope dude or whatever, if you talk about skiing, you can ski up a hill, that's a positive slope. You can ski down a hill, that's negative slope. You can ski on the horizontal, but can you ski on a vertical? No, that's called jumping, right? You cannot ski on a vertical. There is no slope. The slope is undefined. Okay? So what's the other way to do it then? If I can't have a calculator and I can't do m and b, then I must have to do a table. Now, tables are easy for these because it says pretend that it's an equal sign. X equals 1. That means x, I could put down a million ones here, x will always be 1. No matter which y's you pick. So I can pick -4, -3, -2, -1, 0, 1, 2, on to infinity. Okay, whatever numbers you want, it does not matter. Okay, so most people do not do the table. I always think it's a good idea to put a table in there just because it kind of like reinforces what you're doing. So if we look at the first one, over 1 down -4, over 1 -3, over 1, there you go, there's your vertical line. Now some people just do it where they go, okay, go over to x equals 1, and they know that they've got to go, if they're at x equals 1 right here, then they say, oh, well, you can't go this way, you have to be able to go this way, and then they say, oh, that's how they figured out that it's a vertical line. I don't think that always works, honestly. Okay, so since it's a dotted line, and I've kind of made dots here already, you have to make like this dashed line through it. Make sure you put arrows. They will mark you off if there are no arrows on there. And now you have to figure out which way to shade. Now this is a less than sign, and it's really hard to do, means go down, but there's no down here. It's only right or left. So you look on the right and the left on your axis, what numbers are less than 1? And 0, -1. So it's this side that you're shading. Now, another thing that they're really picky about on the Regents is where you label the line. So you are labeling on this side of the line because that's the area where it's less than 1. If you do it on the blank side, the other side, they will mark it off. Okay? So x equal line, vertical line. Some teachers teach it, well, you can't put it in the calculator. So, and then they say, well, if you can't put it in the calculator, then it's a vertical. Some teachers teach it that way. So if this is vertical, then the next one is going to be horizontal. And if you think of the y-axis as being this, you know, going up and down, it's opposite of what you think. That's how I feel. That's how I figure it out. So this is a horizontal line. But we can do M and B with this one. And we also can do a table. We're going to do both. We're going to like overdo it so you guys see and remember it. So if I do the M and B here, now remember y equals mx plus b. There's no x here. But I could add like a 0x to the end of it, right? The slope, if there's no x, the slope is 0 or 0 over 1. And I begin at -3. So -3 on the y-axis. I'm going to just put a little dot here. Go up 0 over 1, up 0 over 1, up 0 over 1. Remember, it's a horizontal line. Now, if I were to do a table, this table says y is always -3, no matter which x I pick, because there is no x in there. So you can pick any x you want. -2, -1, 0, 1, 2, 3, 4. Okay, and if you see, I graphed all those points. This is going to be a solid line because there's an equal sign. Which way I'm going to shade this one? Above, good, because it's a greater than, so. And y is greater than or equal to -3. Okay, you have to be able to do that. You will see it on a quiz and your test. And I can almost, as we go through the year, I'll say I can almost bet 100% something's going to, or very close to 100% that something's going to be on your Regents. They'll have vertical and horizontal lines on there. I guarantee it. All right. Let's look at this next one. So I always start out with these inequalities with I look at the sign first, okay? And it is a greater than sign. So greater than means I'm going to shade up. There's no equal sign. So that means it's going to be dotted. So those are the first two things I write down. I know it's going up and it's dotted. So just to remind myself that when I go draw the line, I don't want to do all this work and get points off for not drawing my line the right way. And I'm going to do this one M and B. My M here is what? Aaron? Either one, doesn't matter. What's my M? Okay, how about the other Aaron? What's my B? 1, good. So I'm going to begin at 1. Now, some of you still struggle with this M and B, how to do the slope there. The positive or negative is always in the numerator, okay? So here, because the negative's in the numerator, it means I'm going down 1 and then always run to the right. 2. So down 1, right 2, down 1, right 2, down 1, right 2. I'm going to show you if you really want to get a table, and I'll show you and remind you how to do that in your calculator in a minute. Okay. Now, as I went down 1, right 2, I can go backwards if you want. I mean, I don't like people going the other way, but that's fine. After you get your original one done and you see the pattern, make a dotted line. And again, this was going to be shaded up. And we're going to label it on the side that's shaded. Y is greater than negative 1/2 x plus 1. Now let's go to your calculator. We're going to plug that in. I just want to go over how to check it in your calculator. Okay? So everybody should have your calculator. Go to y equals, clear it out, whatever's in there. Now, if you do not know how to use the fraction button in your calculator, I am going to teach it to you today. It will be, I would say, an easy 5-point advantage on your Regents if you understand how to use this alpha y equal or fraction button. Okay? So, is everybody ready? We're going to hit alpha y equals number 1 for numerator denominator. Does everybody have that up there? Then I'm going to have a negative 1 in the numerator, arrow down, and put a 2 in the denominator, and then arrow right out of it. Raise your hand if you want me to do that again. Again? Okay, so let's clear it out. We're in y equals. I'm going to hit alpha y equal. Hit number 1 for numerator denominator. Did you get it? Alpha y equals. Oh, you have the older calculator. You have to get a newer one. Oh. Yeah, you got to get one from the bin back there.
I was going to say, why isn't that thing showing up?
Yeah. Go ahead. I'll wait for you. You can grab the new one. Yeah, so if you don't have one of these newer calculators at home, then yeah, you can't use the alpha y equal button. And if you have, there's some calculators, if you do have at home, that you think are an older version, we can update them so that they can do this. And some can, some can't. All right. So again, Riona, alpha y equals. Oh, mine didn't work that time. Alpha y equal number 1. Negative 1 on the top. 2 on the bottom. Arrow right out of it. Now we want an x there. And was it -3? I forgot. +1. Oh, +1. That was off totally. Now, was it greater than or less than? Well, greater than. It is on my calculator. It's already greater than. Does everybody remember that up arrow? I want you guys to back up. Yours might have an arrow in it that's not right. I'm going to show you how to do it. Back up to where it starts jumping before the y equals. Does everybody see that? Miles, are you with me? Because you're not on your calculator. Are you? Okay. So here, I just hit enter, and it'll go through a bunch of them. That's less than, down. And then it goes through some different ones. There's a dotted. And actually, dotted and solid don't matter on here. You guys just have to know it. So I want the greater than. Hit graph, and then it should match your picture. Okay? Again, no matter what calculator you have, even the most expensive ones don't do dotted and solid. I mean, you can put a dotted line in there if you know what it is, but it won't automatically it won't give you greater than or equal to. It'll give you just dotted. All right. Let's go on to the next one. Oh, I want to go back here. Again, if you want the table instead of M and B, you're going to do second and table. And you just pick out the ones that are the nice numbers, okay? You won't want to graph 7 over 2 or 5 over 2, okay, for your table. All right, one more on this page. Okay, so one of the most difficult parts of this problem is a lot of you still struggle with getting things into y equals form, which I believe is T1 on IXL, okay? So if that's something that you're struggling with, you want to try to practice that. The first thing you're going to do is minus 3x from both sides. Now, what most of you, or some of you do, is that you know that step, but then when we get here, a lot of you say that's 7x. You cannot combine those. They're not like terms. So you just have to write them next to each other. It's either 10 minus 3x or negative 3x plus 10. I'm going to write 10 minus 3x. And then the last step is to divide everything through by negative 5. And I get y. And what happens when I divide by negative? Does anybody remember from last year? What happens to those signs? They flip, right? So this becomes less than or equal to negative 2. What happens to a negative divided by negative? Comes a positive 3 over 5x. Okay? Now we can do our M and B. Or we can do our table if you'd rather. But like I want to practice M and B today. All right, I wrote it backwards on purpose because the Regents will do that also. So a lot of you will look at that and say the M is negative 2. It's not, right? What is the M? It's 3 over 5, right in front of the x. And my B is negative 2. So I'm going to begin at negative 2 on the y-axis. I did notice some of you beginning on the x-axis. You always begin on the y. And this one is positive, so that means I'm going to go up 3 and right 5. So up 1, 2, 1, 2, 3, right 1, 2, 3, 4, 5. We only have room for 2 points on here. Again, this is going to be a solid line, and it's going to go up, so I want to get a solid line. I think I'm a little off there, but okay. And again, this one we thought was shade up when we started, but actually when it flipped, it was shade down. Oop, I don't want that. And we want to write our inequality. We want to write the original inequality inside this shaded area. 3x minus 5y is greater than or equal to 10. Now, a lot of times, like you'll see on, I think it's, I don't know if it's T1, I'm not sure which one it is, but it'll say, is this a solution to this graph? You either have to go graph it and see if it ends up in the shaded area, or you have to actually plug it into the equation and see if it works. Now, this is why you have to know M and B, because they're now going to give you a picture, and you are going to have to now write the inequality. So the first thing you have to do is find the y-intercept or the b. And then you have to find the slope, which is your m. Yep. And then figure out if it's solid or dotted. So let's do the first one together here. There's 2 of them. Okay, so first, okay, that's okay. So first we're going to just look at the line. It's dotted and it's shaded down or below the line. So down means less than, and it's dotted, so that means there's no equal sign. So we know it's going to be just less than, not less than or equal to. Okay, so I'm going to start writing my equation. Y is less than, and I'm just going to put mx plus b here. And then over here I'm going to give my m and my b, and then I'm going to rewrite my line. This is the work the Regents want you to show. Okay? So on this one, I'm going to begin at 1. Now, just like when you read, this is how you find slope. Okay? You start, when you read, don't you go from left to right? You've got to find another point going to the right. That's why I say, even when we do slope, we always run to the right. We take a point, and then we try to find another that crosses. And honestly, I struggle with that sometimes. Sometimes I don't pick the first point. I look at it, and I have to back up a little bit, and I say, okay, it looks like to me down here somewhere that it crosses. It doesn't have to be the first point that it crosses. It could be any point. And then when you count, some of you still have difficulty because you start on this line counting 1, but it's the next box. So this is down 1, 2, 3, 4, 5, 6, 7, 8, down 8, and then over 1, 2, 3, 4. So my slope is down 8 over 4. Is that correct? Can I leave it negative 8 over 4? You got to simplify it. So when I simplify it, it simplifies to, well, and that can simplify again to negative 2 over 1. So look at it. It says if I went down 2 over 1, oh yeah, now I see it, down 2 over 1. But sometimes, like I said, it doesn't really matter. It turns, as long as you can reduce it, it's the same thing. So now I'm going to write my equation. Y is less than or equal to negative 2 over 1x plus 1. Oh, no equal sign, sorry. Just less than. And then you write it, remember, on this side of the line. Y is less than negative 2 over 1x plus 1. Okay? So you have to be able to pick that m and b off the line. Does everyone see why it's so important to know how to do that now? Okay, one more. Okay, so let's look at this one. The first thing, I know it's solid, which means there's going to be an equal sign in it. It's shaded up, so it's going to be greater than. So I know it's going to be y is greater than or equal to. And I'm just going to write mx plus b just to kind of give you a reminder that even though it's inequalities, we still use mx plus b. M equals b equals. And I think Seth already had the b. What was the b, Seth? The b is positive 3 right there. Begin at positive 3. And now this one's a little bit easier to see, I think. No, I'm going to go down here. Down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So down 5 over 4. And you can't reduce that. So that was the actual first point of intersection. So my line now is y is greater than or equal to negative 5 over 4x plus 3. That's the biggest thing with slope. You always got to go to the right. Take a left point, go to the right point. Up is positive, down is negative. Okay, so now is when the time you're going to really need the colored pencil. Not all right, so last thing we're doing in our notes today is we are graphing two inequalities together. So what I'm going to tell you is when you are graphing the two inequalities together, you want to graph one of it in its entirety. Get your line, whether it's dotted, solid, whatever, put your shading on there, label it, then go ahead and do the other line. It's going to make it a lot easier because some kids
graph both the lines, and then they try to figure out the shading, and then you're confused because you can't remember which line's which. So one it's in its entirety, then do the other one. The two colors really help also. So on your Regents exam, you can use a pencil for one. If you're really confident, you can use your pen for the other one. So your graphing is going to be just like what we were doing before. So let's take a look at number 1. I'm starting off with my x is greater than or equal to 3. Now, I always like to make myself a little list before I go and I graph these. My list would consist of what kind of line would this be? It's a special line. It's either vertical or it's horizontal. Seth?
Is that vertical?
This one's vertical. So I write myself my little note. It's a vertical line. If you like to make the table, you could go ahead and make your table instead. I like to write that it's a vertical line, though. So the next thing I put in my list is what kind of a line am I going to use to draw it? Am I going to use a solid line or a dotted line? Solid line. And then normally I would write which way am I going to shade, but this one's a little tricky because it's a vertical line, so it's different than normal. So I'm going to go on my graph here to where x is 3. And I'm going to put a few dots so that my vertical line is nice and straight. So I'm going to go ahead and draw it. Luckily, because of the computer, I can draw a nice straight line now. Never could before I found that little thing. So again, we want it to be greater than 3. So am I going to shade towards 4, 5, 6 on the right side? Am I going to shade towards 2, 1, 0 on the left? To the right. So I'm just going to put some shading over here. And in my shading area, I'm going to put my label, x is greater than or equal to 3. So what kind of line is our other line? This one's also a special line. If x is vertical, y is horizontal. So this is a horizontal line. Again, if you prefer the table, you can go ahead and draw yourself a table. Whatever helps you graph it. Now, will we have a solid or dotted line? Dotted, because it does not have the or equal to. And will we shade above or below the line? Below. So we're going to shade below. And that's my little list I make every single time I go to graph one of these so that I remember to do it correctly. So I'm going to go to where y is -2. Again, I'm going to put a couple of dots so that my line is nice and straight. So I got my dotted line there. If you're using your pencil, you forget to make it dotted, you can go ahead and erase a little bit to make it a dotted line. And then we have to shade below the line. What do I have to write in my shading? I have to write the name of my inequality. This is y is less than -2. Now, since we graphed 2 of them at once, see over here where the shading is in both of my colors? I have to put an S over there because that's our solution set. That's our answer to the whole problem, is that little section of the graph over there. So what they want us to do, it says up here, is to check a point in the solution set. So somebody pick for me a point from over there in our solution set. Any point. Any point.
5,
Okay, 5, -5. We can use that one. So all we have to do is check it into both of our inequalities, see if it comes out to be true. So our first inequality was x is greater than 3. What number would I plug in for x? 5. So is 5 greater than or equal to 3? Yeah. Yep. So it works in the first one, so it checks. So now I'm going to try it in my second one. Y is less than -2. What do we plug in for y? So is -5 less than -2? Yep. So it checks. It works in both, so that means it is a solution. Now keep in mind, the reason we're doing the shading is because there are lots of different solutions to that inequality. So that's why we shade it, to show all of them. All right, let's take a look at our second one here. So y is greater than 2x minus 5. Again, I'm going to make my list of information. What's my slope here? Yep, so we put it as 2 over 1. What's our b value? Where do we begin? Negative 5. Will we have a solid or dotted line? Dotted line. And will we shade above or below the line? No. This one's a shade above. It's a greater than, so we want to go above the line. So I'm going to start at negative 5. That's where we begin. Put my first dot. So I'm going to go up 2 to the right 1. Up 2 to the right 1. So once you get a few dots, use your straight edge. Now I have a lot of kids who get confused at this point because they struggle with the shading. So if you have to shade above the line, what I always tell them is put your pencil right on the line and then just start going up. And that's your shade above. Then you got to shade the whole part of the graph above that line. And I label my y is greater than 2x minus 5 in there so that we always have our label on there. Our second inequality, though, I can't graph that yet. I got to get that so y is on its own. So first thing I'm going to do is subtract my 3x. So I get 4y is less than negative 3x plus 12. And then what do we do? Good. Divide by 4. Now, I can't actually divide 3 by 4 without getting a decimal. So I don't want the decimal since I'm graphing. So I'm going to leave it as negative 3 over 4. But 12 divided by 4, I can actually do that. I get a 3. So our slope is negative 3/4. What's our b? 3. What kind of line? Solid or dotted? Dotted again. Dotted line. And will we shade above or below? This one we're going to shade below. Down 3. This one you're going to have to work backwards to get 3 points at least so we can get a nice accurate line. Again, when you go to do your shading, put your pencil on your line and start moving it down so you can shade below the line. And then where it's shaded by both, put your nice big S. That's our solution set. We have a pretty big solution set this time. So again, we have to pick a point from our solution set to check. Whenever possible, I always like to use the point 0, 0 because it's usually pretty easy to plug 0, 0 in. So I'm going to write my 2 inequalities down here. Okay. So for the first one, we put 0 in for y. 0 in for x, so that means I get a 2 times a 0. So that gives me 0 is greater than 5. Is that true? Is 0 greater than negative 5?
Yes.
Yes. So it worked in the first one. Let's try it in the second one. 3 times 0 plus 4 times 0. Let's see if that's less than 12. Well, 3 times 0 gives us 0. 4 times 0 gives us 0. So 0 plus 0 is 0. Is 0 less than 12? Yes. So there we go. So because a point in the area we're calling the solution set works, that means we found the right one.